let's talk about the system development life cycle. Any computer information system can take a bit of effort to develop, and so it's a smart thing to break it down into distinct phases. For example, there's the analysis phase where you talk to customers and find out what the problem is, what they need. There's the design phase where you take that information and you design an answer to the question, a solution to the problem. There's the build phase where you construct the system, and the deployment phase where you hand it back to the customer. And finally, the support phase where you help them use it to the best advantage. Each of these phases requires a different kind of thinking, a different kind of work, different activities, even different ways of communicating. In the analysis phase, you're talking to the customer in their language. In the design phase, you're talking to other technologists in their language. In the support phase, you have to respond to every interrupt, to every new problem that comes along. In the design phase, that just messes up your train of thought. So it's good to break the system development process down into these phases. Now, we used to think that these happened one after the other, kind of like a waterfall, where you would sit down and you would analyze everything that needed to be analyzed, and you'd throw the resulting set of documents over the wall to some sort of design team, and then they would figure out the best solution, and then they'd throw it over the wall to some other coding team, and blah 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 blah. Down the pipe it would go. Big systems take, a year and a half, 2 years, 3 years to develop. And by the time you're done, what you've built doesn't look anything like what anyone wanted. So we realized we needed to chunk this up, to break it up into smaller chunks. And more importantly, we needed to think about this whole process as a cycle. It's something you do over and over again. In fact, if you break the system down into a small enough piece, you can take just a subset of the features, completely analyze what they need to do, design a great set of features, build them, and show them to the customer in just a couple of weeks or maybe a month. That way they can tell you right away, yes, that's the system we want. And you do this a couple times and pretty soon you've got enough functionality that the customer is ready to go. This is called an iterative process. Now, the kinds of activities you do in the cycle, whether it's an old-fashioned long cycle or one of these new cycles, the activities are the same. So let's take a look at each one of those phases. Now, first of all, usually there's an existing system. Usually there's, even if it's just paper and pencil, there's something that the customer does today, there's some software that they use today that they use to do their job, to do whatever it is they want you to do better. So listen to what they say about the old system, what works, what doesn't. Everything in this cycle is designed to take what the customer says to you and turn it into something of value for the customer. It's all about the customer here. Now you go to the next phase, the analysis phase, and there you go deep into understanding the customer's perspective, understanding what do they need, what pain are they feeling, what's the problem. You can do more interviews. They'll tell you exactly what they want. Sometimes what they tell you they want isn't really what they need, so it's useful to go on ride-alongs, to actually do their job with them and observe them doing what they do. If you've got a large customer base, you can do surveys. There's all sorts of ways of finding out what does the customer need, how does the customer think about it. In this phase, you create diagrams and documents, and they're all in the customer's language. If they call something with particular names, you use those names. Now, you may not use those names inside the system. You may not write your software with those names. But the documents and diagrams that you create in the analysis phase are for communicating between your team and the customer. Now, once you've got that solid, you go on to the design phase. Now, this is where you've got a pretty good handle on the problem, Now you want to think about what's the solution. What are the range of different solutions? Some of them might be expensive. Some of them might take a long time. Some of them might be very cheap. You look at all of the spectrum of what can we do for this person? What can we use? What technologies are available to us? What other products can we buy that might do the same job? Again, you produce documents and diagrams and that sort of thing. But at this phase, you also start prototyping. Early on, you can even use little bits of paper and show the customer, okay, you'll have a screen like this, and then it'll do something else. What do you think? As you go along, the prototypes get more sophisticated. You go to wireframes and mock-ups and things like that. You might even write code to show them this is how it'll actually feel. Code you might end up throwing away. The important thing is, as you do your design, get feedback from your customer. The stuff you produce is for your team, for the design team. Some design teams are scattered all across the globe, and they have members that speak all sorts of different languages. So the language you see in design documents is very structured. Later on in the course, we'll show stuff called pseudocode. We'll always have different diagramming techniques. Design documents are important for communication. They're not to be any more important than that. If they don't communicate, they're not any good. Now, some folks move very quickly through the design document phase, and they actually move right to the code, especially if you've broken it down into a tiny piece. You don't do a lot of documenting. You just get to the code, you make sure everybody understands what needs to be built, and you build it. This is production code. This is code that works, that's reliable, that's well tested. It also might be other products from other companies or other people if you're using open source. It might be other services. You might use Google for your search engine, for example, instead of buying one. Or goodness, no one ever writes that stuff anymore unless they're in that line of work. The important thing in this phase is to build something that works, something that the customer can use and is reliable. Don't worry about making it fast. Don't worry about making it scale up to 1 million people until you've got it working. Now, knowing that it has to scale to 1 million people will influence your design. It'll change your architecture. But at this stage, you want to avoid what they call premature optimization. Trying to make it too focused before it works for what you're trying to accomplish. Now, when you're ready to deploy, it's a different story. You're going to put it in the hands of customers, and then it does have to be fast. It does have to scale up. When you deploy a system, an IT system, it's called rolling it out. You give it to some customers, then you give it to more customers, then you give it to more customers, and you scale up your operation as you take on more and more customers. Two things are very important. One, if you're replacing an existing system with a new system, you have to make sure you don't disrupt people's jobs. They have to be able to switch cleanly from one to the other. Second, as you're ramping up from the early adopters to a wider audience, you have to make sure that you don't mess up your current customers. You know, if you add 1,000 more customers and the system dies, that's not good. You have to scale up intelligently. Rolling out systems is a very interesting discipline. And then finally, you're in this wonderful situation, again, where you've got real people using your system, and you can actually learn so much in the support environment. Some people think that the job's over at this point, but no, in fact, the job is just in its richest phase when you've got real people using your product. Strangely enough, people will ask you for new stuff, but they won't like it when you give it to them. People don't like change if it leads to more work. I mean, who would? So if you've done your analysis correctly and you've built the system and you've gotten your feedback from the customer, you know it's the right system. Help them over that little barrier through training, through close support, talking to them, calling them up, making sure they're happy. Separate any kind of first impressions they might have just because it's different from what really might be a problem. If you've done your homework well, you'll find that people are very happy with the new system after a little. Some of them take to it right away. Each one of these phases includes testing. The kind of testing you do to make sure that you're doing it right is different in each phase. Let's go around the circle again and talk about how you check your understanding at each level. In the analysis phase, again, you've got those documents. You say this, in our course when we're working on websites, we'll show mock-ups, we'll talk about behaviors. When we do databases, we will show them business rules and entity relationship diagrams, and we'll show them a schema. At this point, you show them what you think you know, and they tell you whether you're on track or not. You do this in document reviews, follow-up interviews, whatever you can do to get a little bit of their time and get the feedback. In the design phase, you may not have running code yet, so you can't actually test it against a test framework, but you can use those prototypes. You can show them to the customer. You can show mock-ups and say, okay, here's the first screen, here's the second screen, see, is this what you want? As you get closer to real code, you can actually show them working code, and you can run programmatic tests. There's a very interesting trend going on in software development called executable specifications, using a language called Gherkin in a tool called Cucumber. But we'll deal with that later when we talk about programming. When you're actually building, you've got code now, it's production code, it's ready for someone to actually use it and try it. You can use something called alpha testing. That's where you take the other people on your team and select customers, put them all under a non-disclosure agreement, and actually give them the code, have them use it. You have to be careful here. If you must always give customers what you are prepared to release. Don't show them half-finished work. Don't show them first drafts, because they might actually say, that's good, let's ship that. Then you're done, and you better have code that you're ready to deploy. In the next phase, in deployment, you start to roll it out to a larger and larger set of customers, and this is called beta testing. It's outside the team. You give it to a kind of person called an early adopter. These are people who love risk, who love having the latest and greatest things. And what they give you is information, and usually you give them the product. It's a nice trade. It's a nice trade. But you have to be careful at this point, because you may get feedback you're not prepared for. You may hear from your customers, that's a great product, but you know what I'd really rather have? I'd really have a product that does this other thing. For example, there's a photo sharing site called Flickr. When they started out, it was something else. I don't know, a dating site or something else. I don't know what it was. And when they did their initial testing, their customers said, well, I don't really need that thing, but I love how easy it is to share these photographs. Can I just use it to share photos with my friends? And they changed, and they built something that shared photographs. Very successful. So be prepared to listen to your customers, and be prepared to change your plan if that's what you need to do. Finally, you're back in this wonderful state where you've got real customers using your system. Now you have real data. Your product itself can tell you, well, they clicked on this, and they said that was good, they bought this, they produced that. You can find out what the customer really does in real time, and there's nothing like real data to help you understand how the product is succeeding or failing and what you need to do in the next iteration. There's a special form of this called A/B testing, where you actually deploy two different versions of the same page, for example, and you see which one works better, which one does the customer end up succeeding with, or which one causes them to actually buy something. This is great for finding out the details of what should we do next. It's not so good about finding out the strategic decisions you have to make. This kind of testing will never tell you, should I produce an iPhone? or some other breakthrough product, but it's great for optimizing an existing product. So we've gone through the different phases, the 5 phases of the system development lifecycle. You may have seen that I've left out planning until this part of the presentation. That's because planning is part of every phase. It fits in between every phase of the project, and it's done over and over again. For example, you've gotten data from your customers from the existing system, and they've said, this doesn't work, this works. They filed change requests or bug reports or whatever. You get a few people together, you give them a little bit of money for a budget, and you ask the question, is there really a project here? Is this something we should do? Is there a market for this? And you do a little bit of planning. You know a little bit about the system, and you plan the next phase. You go through and you do your analysis, and you understand the problem in greater depth. Now you go back to planning and you decide, well, now that we know about the problem, let's plan what it'll take to do a solution. And similarly, every time you go through a phase, you replan. It's called a stage gate system. So you go through your analysis, you sit back and you say, okay, how long is this going to take us? What is it going to take? Are we going to succeed or not? You go through the design. You find out, well, is this technically feasible? Can we do this with our current budget, our people, that sort of thing. Each time you look at it, and you have to make that hard decision, should we continue with the project? Don't wait until you're way down the road before you cancel a project and waste a lot of money and time on it. Planning happens in every phase. Why? Because planning reduces uncertainty. When you start a project, you can estimate all you like, but you don't have a lot of information. You could be off by a factor of 10. Your budgets, your schedules, they could all be so far off that they're just misleading. Now, sometimes you have to finish something within a certain amount of time. Sometimes there's a market window. Well, you do your best. But planning reduces uncertainty, and in that way it reduces risk. The other thing that planning does for you is it balances what some people call the iron triangle. This is the set of time, money or resources, and features. You may have heard that expression, I can give it to you fast, I can give it to you good, or I can give it to you cheap. Pick two. What that means is, if you have a certain set of features that you have to deliver, it has to do this, it has to do that, it has to do this other thing. Well, effort takes time. Effort takes resources. You can sometimes throw more resources at a problem and have it happen faster. That's tricky, though. What you can also do is you can say, well, we don't need that and we don't need that, so let's take those features off the table. Now, how much money does it take and how many months will it take? Each time, that balancing factor of time and money and feature set is exactly what the people who do project planning help you with. It can be a difficult conversation to have, and there are some people who are very good at it. These are called project managers. You might enjoy being a project manager if you're the kind of person who really understands technology, can learn all sorts of new stuff from different disciplines, because you usually work in a team of different kinds of people who are in all of those phases. But what you really enjoy is helping a team do amazing things against the odds. I mean, it is very unusual for a software project to come in on time and under budget. In fact, a lot of software projects simply fail. They're just difficult. And when we talk about programming later in the course, you'll find out why programming is difficult, why software is difficult. A project manager is the kind of person who can deal with complexity, helps getting people together and getting a job done with a team. It's a fun job. It can be tough, but it's a fun job. The important thing to remember is that every time you update the plan, it's still wrong. It still is inaccurate. General Dwight D. Eisenhower said that plans are nothing, but planning is everything. This is the guy that was in charge of the Normandy invasion in World War II, a gigantic undertaking. This is a guy in his presidential administration, they built the interstate highway system, giant projects. You'll get people who want you to start out with a plan and to stick to that plan all the way through the whole cycle. As much as I would like to say that's possible, it really isn't. Learn from each thing you do and update your plan every time, and you'll ship faster than someone who doesn't. That's about all I can say. So let's summarize the system development lifecycle. There are these phases: analysis, design, build, deploy, and support. And they have individual tasks for each one. First you understand the problem, then you understand the solution. You build the solution, then you scale it up, you deliver it, and then in support you help the customer and you listen to them. Each of these phases has unique kinds of outcomes or deliverables. User documents, things that are in the user's voice, technical documents and prototypes. Eventually you get to the point where you've got functioning system and you can hand that to customers. The ultimate goal of this thing is to have people who are enjoying themselves, who can work a little bit less than they could in the last system, who are delighted and they're happy that you helped them out. And then remember, all the way along the line there's planning. In between the analysis and the design phase, in between the design phase and the build phase, in between blah blah blah, in between every phase and the next, you go back and plan.